All right. Our final new learning for this week is graphing rational functions in the form y equals ax plus b divided by cx plus d. For this form, notice now we have a variable in the numerator and the denominator, but we have all these numbers. A, B, C, and D will be numbers. And so we use the relationships between those numbers to find our asymptotes. Remembering that we're not allowed to divide by 0, to find our vertical asymptote, we take our cx plus d, make it equal to 0, and then whatever the solution is, that's our asymptote. And then to find our horizontal asymptote, if we think about as x is getting bigger and bigger and bigger, or smaller and smaller and smaller, these numbers are going to have less and less of an impact on the overall ratio because they're staying the same. And so we're going to be slowly approaching whatever this ratio right here is, because these are the same, but it's always going to be a little bit off from this ratio. So the horizontal asymptote is actually this ratio right here. So it's y equals a divided by c. Okay, so let's do an example. If I have the function y equals 3x minus 6 divided by x plus 2, I can start with my horizontal and vertical asymptotes. My vertical asymptote, I don't give myself much room, so I'm going to abbreviate it, is at x plus 2 equals 0. So x equals negative 2. Or we could just look at this and say, okay, what number would x have to be to make this whole thing 0? And that's going to be our vertical asymptote. So I'm going to go ahead and draw that in right now. Here's my vertical asymptote at x equals negative 2. And then my horizontal asymptote is at y equals a over c. In this case, my c is invisible, but remember we have this invisible 1 right here. So y equals 3 over 1, or just 3. So I'm going to go ahead and sketch that in. Y equals 3. And then from there, we can go ahead and make our table again. And just like last time, I'm going to center it around that asymptote, pick some points on either side. Okay, and then I take these points and substitute them in for x in my function up here. So I went ahead and did the math ahead of time this time just to save a little time on the video. So when x is negative 3, then we substitute that in and y ends up being positive 15. When x is negative 4, y is 9. When x is negative 5, y is 7. when x is -6, y is +6. So I think that's enough to give me a branch. I went ahead and did 4 numbers instead of 3 like I did in the previous examples because I noticed that this one was so big it would be hard to graph, and I wanted to make sure I had some that would fit nicely on the graph. So I have a point at, I'm going to start with this top one, -6, +6, so 2, 4, 6. I have a point at -5, +7, -4, +9. And then I know my next point is way up there, so I'm just going to go ahead and kind of sketch this in, try to make it symmetrical. And then going the other direction, at -1, I got -9. At 0, I got -3. 1, I got -1, and 2, I got 0. I would encourage you to actually practice for at least a few of these numbers, substituting substituting the numbers in and making sure you get the same numbers. There's a lot of room for error with order of operations, especially if you're just plugging it straight into a calculator. So you want to make sure that you can do that process easily. Remember, if you are putting it straight into a calculator, you're going to need to do that. Okay. So then these points, I have a point at -1, -9. So there's 2, 4, 6, 8, 9. I have a point at 0, -3. I have a point at 1, -1. And I have a point at 2, 0. So here's my other branch. And just kind of sketch in a nice smooth curve, try to make it symmetrical. And there we go.